Hey, good evening. So, and welcome. I wouldn't say to my channel, I would say to my video. This material I intend to be, just a slight educational video material about some, I would say decommissioned industrial hardware. Some of it might be older, some of it might be less older, but yeah, there are things that, let's say, they come from an industrial scenario, and as per general level of quality of industrial, where there is industry, these things are above as quality and the price, above the consumer general consumer electronics, and above the average computer type one has at home or in the office or whatever. So without further delay, I will just go and present this. As it's obvious, looks like a box with a bunch of communication ports, and here some aluminum fins for cooling, and of course more fins here for passive cooling, and again cables, and that's all. So of course it is industrial. It has it's very versatile. It's built to fulfill different purposes. It can be a router. It can be a server. It can be a data acquisition device. It can be a client. Different type of networks, or different type of connection with different type of industrial devices that can communicate via serial ports. Could be RS-232, could be RS-485 or RS-422 probably. I don't know. The BIOS has options for this port, so they can be configured. So further on, I was tinkering with it a bit. It's quite sturdy. It's quite heavy, as this part you will see later. This part is molded. It's aluminum molded. It's quite heavy. It's what it has to be to make secure the entire motherboard assembly with processor, north bridge, south bridge, and the Ethernet connections. Chips are properly cooled. So first of all, I'm gonna present fast here what we have. So we have the network ports. We have the monitor, standard monitor. I will hook that monitor. I will hook it here and start the device later on a bit in this video. Regarding the ports, I will quickly present them as they are already. This unit particular, it serves as a router. So it has a scenario where one of the Ethernet adapters is assigned as LAN 1, the other one is LAN 1, then a VGA connection, to connect a monitor like on any other normal PC, to USB, to 0 ports for whatever other devices, booting. It supports also booting via USB and via internal devices. That will be later on. I will explain a bit. And this says it's an option, so this card can be removed and replaced with something else. This is a dual Ethernet card, and the maker labeled this port as LAN 2 and WAN 2. So it was a router with with 2 WAN ports and 2 LAN ports with load balancing and some other features. That the software as installed as firmware, or let's say, was able to to provide out of the device itself. This is the power connector. This is the power connector. I know it's visible, maybe a little bit. Something like that. Okay, so power connector here. A voltage starting from 10 to 30 volts DC can be supplied. Current is quite high, so it draws 7 nominal current is like 7.58 amps, but it can even go to 10 amps. So yeah, it's quite power hungry because inside, yeah, you can accommodate different things. Then this is the power push button. It's a push button. It's not a switch. Yeah, like any ATX system. Then two USB, two serial ports, and here two more. Here it's the reset button, I think. Yeah, yes. It's the reset button, practically shorting these two pins. The system is resetting in case it hangs out. So more USB ports for different yeah, let's say devices to be connected, like storage, external storage, or whatever other mouse, keyboard, or whatever other scanner or data acquisition device or whatever. This is a blind now. It's actually let's say it's just a metal blockage. I doesn't come the name now in mind. Yeah, whatever. Yeah, this can be removed, and the expansion card, the PCI card, can be installed. I will show you later on. So this is all. Nothing fancy. No shiny buttons. No, I don't know, pinky thingies. Nothing. It's just black and built as a brick. I have to, keep it. Have to use a bit of force to play with it like that. So yeah, I will show now, because I removed some of the screws on the top and on the side. We'll show what's inside. So just one thing to mention here, on top of it there is now it's sealed, but this is an opening to a slot, a compact flash card slot, of course, and the card can be accommodated here for booting. It supports booting for a lot of devices. There are a lot of ports inside. I will show you in a minute. And this now it's, let's say it's sealed. I like this warranty thingy, and I didn't remove this. I prefer to remove the entire the entire side here rather than remove this and violate the terms of warranty and services. So going like that, I will take this out. Yeah, it's a little bit tricky here. I have to be careful. So as you see, it's obvious. It's just a panel. It's made of. This is I think it's made of iron. Yeah, it's from iron. So it's iron here. Here's some tough sponge to just to gently press on the extension cards if there are any, and to just fix them, and not to leave some space for movement. So that's all from the side. And now, as here, now we can see they are sealed by the fabric. This metal brackets, as they are called. These are this is the computer itself, the first one. The second one, it's from the network card, and the third one is available, so it can be installed. Can be installed a different type of extension card. Can be also, I don't know, a network card, a SAS card, or whatever. Okay, going inside, I will slide it like that. Hopefully the camera does the justice. And here we have something like some power connectors for different type of internal drives. This is a Molex 4-pin. This is SATA for SATA. This is also Molex, and of course the well-known connector that's used for floppy, but not only. I have something here, for example, this adapter of one compact. Oh, this fell off. It's a compact flash card, and this one can be powered on using this type of connector, so it's not only for floppy drive. Okay, so as it looks like, yeah, as I mentioned, for the soft, because the the screws were not in place, I just removed them to not waste time here. This is the side that is the, let's say, it's the cooler. It's quite heavy. It's quite thick. It's aluminum. I think it's molded under pressure. By the sound of it, it's heavy. It's dense, and it's obvious. The purpose is obvious to have to make sure that the heat is properly disposed of in the surrounding environment. So nothing fancy. It's just, it's well machined. Clearly, the surface has to be perfect, flat, and of course, every screw it's designed by the way it was made. All these sub assemblies, by the way they're made, they are clearly designed to be precise and to press. I will show you in a minute, to press the heat sinks of the important chips on the motherboard, to press them equally, without any gaps of air, which might lead to a problem in that heat dissipation. Okay, going next, put this away. So now I think more of it is visible. I hope I will get it a bit closer. Let's raise the camera just a little bit. Okay. Oh, maybe that's too much. I will control the camera from here. Better like that. It's not a professional camera, but should do. Now, okay. Now it's quite okay. So, here what we have, as I mentioned, we have the motherboard. We have a slot for memory. The configuration supports two sodium memory modules. It's DDR Type 3, and I think it's the one that's used also in laptops and different small servers or whatever other devices can accommodate this small form factor. So as it's obvious, I don't know, I put it like this. Hopefully it will be visible. Going next, we have the processor here. This is also full aluminum. It's a little brick of aluminum. And this one is for the North bridge, and this is the South bridge here. I think it's, I don't know, it's Intel, not sure if it's GM45 or, dedicated set for these industrial devices. Further on, we have the two internet. I mean, it's not internet actually. It could be anything. It's just two network gigabit cards. Here, probably some I don't know, probably some MOSFETs or whatever other auxiliary devices are needed to serve the processor and the things around it. Yeah, this is practically a total. Oops, my screws. Yeah, like this. Yeah, here we have the other side of the daughter board. We have the second sodium slot. So here it's another one. Now it's populated 2 by 2, so it's 4 gigabytes of RAM in a dual mode channel, because it's an Intel, and supports it. It's of course well made. This is the maybe like that better. Now it's visible. Sorry. So here is the second thin sodium memory module, network card, and compact flash card. Turn it like that. Hopefully lighting comes from above. Maybe I should, for future releases, I should use a second source of light for the presentation like that. So going to next thingy, I'll have a little bit color here. All right, so going to next, here we have the daughter board with standard 22 pin connection, ATX, MOLEX for a power supply. So this is the drive. Yeah, I used it as a router and installed pfSense on it. So this is the best purpose which I could find for it. And some other, some auxiliary components, capacitors, and probably some, I don't know what chip it's doing here, probably some power or whatever other, functions the system needs. So the purpose, I mean, as I was taking it out and mentioned, I would like to take out this, this heatsink here. It's quite beefy. This is on the processor. I have no idea what processor is. Linux is saying something, but I didn't pay too much attention. Now would be an opportunity to see. Probably it's a quality duo. It's generation 7 or 8 or whatever. I don't know. Let's find out. It's for sure it's mobile. It's designed for low power consumption. So yes. All right. Then we go for we take some tools. Let's see a proper bit for this little screws and take it out. All right. Let's see if we are. Okay, looks good. Adjust the tool, and I will slowly release. I'll keep my finger here just to press a bit. I heard the magic noise of the screw being unscrewed. Oops, that one. More. Okay, second. Third. And push a bit. Fourth. Okay, so now they are all. Yeah, I will undo them gently and slowly. Yeah, and equally, or at least as equal I can. So the heatsink will easily get its distance from the. I don't know. I never opened here. Oh, I got one screw. Okay, so I don't know what surprise there will be. Probably the old thermal paste is cooked. Yeah, the third and the fourth. Not sure. Let's see what we find here. So we have 4 screws, 4 little springs. Yeah, that are helping to keep the pressure, equal pressure on the processor die. So we'll try to remove it. I hear the noise. Wow, that's quite heavy. It's heavy. So as it's obvious, the typical like that. Yeah, the typical paste, and this doesn't look too good honestly, because I can see some residues here, and the way the force was distributed over it wasn't the best. No, not at all. So yeah, it's a good idea I removed it, and we'll put it aside here. It's quite heavy. It's solid aluminum. Yeah, it's molded and then machined. So yeah. And our little processor, it's an Intel. Oh boy. Okay. My computer entered standby. Yeah, it's an Intel. It's All right, 2.2, 2.3 gigahertz, 3 megabytes of level to cache, and right, and the speed is 1066. So yeah, now time for taking the processor out. I will show you how it looks. It doesn't look too good, the die. I mean, it's dirty because this default or stock thermal paste is in general, it's cracking. I prefer using pure silicone and not not the crap that they supply generally. So now releasing the screw from the processor, and I don't have my pliers for extracting chips, but yeah, this can be done also with the hands. This is no problem. I just wanted to take it out slowly and avoid touching it, because then I want to clean it. Okay, I don't want to do anything stupid here, but better by the edges it's okay. So I have it now, and I will show it to you in the light. Yeah, you see why I wanted to do this, and yeah, looks like it's a good idea. Goodie. Further on, then I have some alcohol here. It's industrial type of alcohol. It's quite strong, so 1 drop of this will be enough for cleaning all this residues. Oh man, it looks so dirty. So it looks like someone put it. It's not a fingerprint, but it's like a gunk. Okay, a few, 2-3 drops of industrial alcohol just to clean it. Yeah, and then remove all this gunky gray stuff, which now it's cooked by the heat, and it's a bit resilient. So looks a bit better, but it's not finished. Have a look closely, yeah. So you see, yeah, you can see also the camera, because here this the surface of the die is reflective. So it's this composite material. Yeah, so it's obvious it's not fully removed. So we have also to use it here. Here will be a bit tricky because it's more material. Probably this I will use a plastic card or something just to remove it. Yeah. Okay. 1 more drop for the processor. And right. And just a little, yeah, like that. Yeah, a little bit of paper. Yeah, put my tweezers like that and use it to remove this this residue here. Quite resistant. It doesn't look like it wanna give up. Oh, I'm shaking the movement. Yeah, what the heck? Still not convinced it want to go. It's obvious there are some traces on the paper of this bloody gunky thermal paste that they put on stock. Yeah, still doesn't. Finally. Yeah, we have it all. So look here. Yeah, you can see the dirt on it. So yeah. Okay. Good. Now, just a little bit. It's just normal paper. And it's quite good because it doesn't. It's gentle to this special surface. And now I can show you how the processor looks. And looks yes, the surface looks clean without. Yeah, you can see my monitor reflecting two of them actually reflecting perfectly in the surface. So yeah, looking a bit also. Okay, two more little dots, but okay, this is easy. And now I will put the processor back. So it's quite nice, beautiful build. Yeah, it's clearly a processor for mobile. It's mobile use. It's a socket. I think it's 479. Yeah, that's 479 variant. This is of course with little m. It's for mobile, of course. And we'll put it here back and slide it now. Slide it now here, making sure all corners are equally in. And now, just before securing the little latch here, I'll slowly, gently press it so it stays equal. Insert it in, and now, oh, my screwdriver. Okay, so perfect. Now it's in, and it's clean. Checking one more time with the magnifier. Yep. Make sure that's no. Oh yeah, looking good. Looking goody. Now we have to clean this. Yeah, this box here. So that I have to do using a card. I will use a communication card we can have here, and just we're not gonna use alcohol for a moment. I will use the plastic card, so you have the surface here, the plastic card, and you can just gently press. Yeah, as you see, it's cooked. It cracks actually, little pieces. You see, and it slowly but surely can be, yeah, it can be removed without scratching the copper surface. It has to be in perfect contact with the die of the CPU. So yeah, removing. You see, most of it is already off. So we'll go like that. Yeah, you see, so as I mentioned, not at the first stage, there is no need to use alcohol or something. You have like that. Okay, I will not make a line out of this. It is just conductive gunk, and that's not good for nothing now. So yeah, and then just slowly with a little brush removing the big parts. Actually, they are not so big. They are visible. Now more, and now we can use the. I will return my card here. We can use the alcohol to clean it now deeper level and remove all this stuff here. One drop is enough. Just a little paper to just first to take off this. This is how it looks after. You see, still some traces of it, but yeah, we'll get rid of these two. Next drop. So drop by drop, it has to be done carefully and with patience. Yeah, and remove all this crap out of here. Sorry for the language, hope will not get problems with this video. So, alrighty then. Looks like, oh, you see, anti-dropping, so it's not dropping until I press it so that's very good when you have alcohol and you can, two dots here which I found they were quite resistant to my physical action of removing it. So next one, third drop, the magic drop of alcohol is just standard industrial alcohol, nothing fancy, but yeah, it does the job. Yeah, cleaning it a bit. So yeah, it's very nice. This is why the alcohol must not touch this surface because it will destroy the glue that this little sponge has, and this little sponge practically prevents the dust getting into the conductive paste, and of course prevents the paste of being, let's say, the water from it evaporating and being cooked by the heat coming from the processor step. So looks good. One more drop again. So as I said, making sure the drop now it reached the sides, but should be, if I keep it centered, the drop of alcohol should never reach the corners of this square here. So now we have it. Now it's looking a bit better. You see, the copper still has some traces, but that's already far beyond what it was. Perfect. Now our silicone bowl is here, and now we can. So as I said, it's just transparent silicone. It's very good for thermal as a thermal conductor, and it's never. I mean, I remember one time as a test, I set it on fire. Actually, it doesn't catch on fire at all, but yeah, it doesn't burn, it doesn't change. So this is how it looks. Okay, and now I will gently put it on this little die here. Doesn't have to be too much, just to cover its surface, and the rest of it, of course, I can put it on this pink thermal. So the die has already here. I can already distribute it evenly on the surface of this. That's the north bridge. Yeah, now it's done. Perfect, or at least it's good. Okay, so alcohol we don't need. Get it sealed back. Now we have to see it back. So it was like that. This was the position. It has here some side that was already machined because there is a connector. And now I should be slowly. So since I cannot center it, I will use my tools to center it and not moving this big fat heatsink against the processor. So I will set it possible. Okay, try not to move it too much, and get now the square. Right, so there's my screwdriver. Screw here. Don't need the flat. We need now back. Another important thing is now also the screws must be added one by one, and preferably in diagonal, so the pressure is, let's say, the pressure on the processor die is applied as evenly as possible. So never get one screw done completely in front of the other. So they must be equally as possible. All the pressure is applied equally on the surface of the processor and never only on one or corner or one side. That's very important. When it's about finished, now all screws are until the end. Just apply a little bit pressure here, tighten them up so they. I don't have a tool. Dynamometric screwdriver is just a regular one, but yes. And now we have it nicely, and we can continue with tightening it up. I want to, since I have some silicone on this tool, I will just leave it here because it will make very good contact with the external heatsink. So now our heatsink comes in place. As it's over here, there are some traces of silicone here. And I think we can already start packing up. So as a last overview, the heatsink for the processor. Here I will not take it out, I will leave it like that. There's the north bridge, and this is the south. This also gets quite hot, the north one. It's an Intel chipset. And here is the nice static power supply, which is converting all the power from the main input here to the all separate voltages, the normal ATX power supply will offer for a motherboard. Okay, going forward on this. There is something more. We have a little bit of plastic here. I don't know if it's visible on my hand. It's visible in transparency. This has to be here because this is a spacer for keeps the motherboard in its position. So it's already, I don't know if it's visible somehow. That's it. Here. Okay, so now we are going to set this baby on it. Yep. No. Yeah. Not good. So first trial failed. Yes, because this has to be seated perfectly here, and looks like this little bit of plastic went off. Well, I think the approach must be different. Must be something like that. So I should sit this like that. Oh yeah, yes. Now it's good. Spacer is in place. Oh, failed again. Oh my God! So it looks like that's not an easy one. Tough cookie. Right. So come on, little thingy. It gets interestingly. Yeah, maybe I should look here. How it is. Yes, now I've got it. Good. Now, yes, now we'll have to use. Yeah, I have to use this. Yeah, we have to screw back 1, 2, 3, 4 screws. I have to sit them here. All right. Okay. Yes. Chop. Here. Third one. Oopsie. Yeah, they have to be perfectly centered. So never do all full. I mean, they are not yet tight, but already it's so precise. It's already not moving. That's very good because more screws are here on top. Yeah, on upper side, and these are also, so never do them all at once. One, now 2, 3. The third one. So here 2, 3. So 3 on top. They will also center. They are in the shape of cone. So the heads of the screws. So they will also center and seat this heatsink correctly. So yes. Okay. Now I can type them. Okay, this is right. Yes. Now it can be. Yep. Yeah, like that. Goodie. Perfect. Now we have the unit back on. Yeah, sit like this. And we can play a little bit with it since substances are no longer needed. I'll put this back away. Screwdriver, little precision screwdriver, I don't need anymore. So now I can just wrap this piece up and that. Okay. First of all, we'll connect one monitor and the power. I need a VGA. USB keyboard and mouse. And just an adapter to USB to PS2. Then later on, we have the VGA connection. The monitor is already waiting for signal. And now I will put the power connector and wait, because as it's industrial, it should start by itself. As you see, some lights, and now it will be obvious. It will start booting. So it's booting quite fast. I have the heatsink, but I want to pause it a bit just to present. I have a little peek in the BIOS settings, and yes, BIOS is quite complex. Yes, BIOS designed for industrial platforms. So let's control out delete it one time. It's quite fast, it's responding. Now I'm pressing the delete. Okay, I have to trigger the VGA off and put it back on, so the monitor will automatically change. Okay, it looks like control out delete one again. Okay, and this baby is so fast. I thought it a bit, and now we have the BIOS. Let's see. Okay. I will power off and power it on. Right. Okay. And then go to boot manager. Let's just go into the BIOS. Might be F2. I don't know. Okay, I will try a different keyboard. I will try a different keyboard, also USB, but different type keyboard. So this one will have. Okay, so it's reacting. Control. Quick. And key. All right. I hear a bit. Wow. Enter password. Enter current password. That's a surprise. Service. Looks like I don't have the password for it. So, yeah, sorry. Looks like I cannot get into the BIOS. Yeah, probably. Let's try. I'm just trying to. Okay. Password check. Step 1 to resume. All right. So yeah, no BIOS. That's it. But yeah, looks like I need to get the default password for this type of BIOS. It's American Megatrends. I don't know, maybe getting it. Actually, I don't need to enter the BIOS. I just wanted to show you. But since since I cannot enter it, I will leave it like it is. So now, surprise. Okay, now let's put the heatsink. Yeah, sadly. It's moving fast. Now it's loading the firmware for the PSense operation. PSense is a well-known firmware for the router, an advanced router. So that's a very good piece of firmware based on Linux. and it's quite nice. So this will be the primary views of it. It's silent, no noise. Now it's also revised, so this is the inside. So yeah, it's compact. It doesn't drain too much power. A dedicated industrial system. So, yeah. It's loading devices. I will take this keyboard away, get my tools, and finish this video. So, yes, hopefully you liked it. Well, as I said, it's a professional camera which I'm using to capture this video here. Here I can, I don't know, put something. Just a label or whatever, a license or whatever that can be. So let's see if our it's still booting, is not finished yet. I think so. Yes. Alright, so we'll still wait. Features of Union Intel. It's a Core 2 Duo T8 for Happy Beep. Yeah, it's Core 2 Duo. So now we are in the menu for text menu for the PSL application. I will not go into that, as this is not part of the presentation. You can put anything. You can run even Windows 7. You can run Windows XP. You can run have enough RAM. You can run correctly Windows 10 or Windows 11 distributions, or some other flavor of industrial application or whatever other operating system. So thanks, guys. I hope you liked it. So yeah, if you liked it, please share, subscribe, whatever you feel is good for you. I will try to make more of these presentation videos. These devices, which sometimes they are thrown away, or let's say decommissioned out of the industrial environment, and better. I don't know. I can repurpose them or present it to you. And the model is made by a company named Axiom Tech. It's called IPC912. You can find it easily on eBay and then Google in general. So yeah, thanks a lot.